Welcome to our second session of this particular lesson. Initially we mentioned the number of things that you require when you're planning to carry out a quadrant method study. So in this case, there is a procedure to be followed when you're carrying out this. So first and foremost, it is important that you need to select a suitable study area. That means you need to choose. If you are looking for a particular species of a plant, then you need to identify which part of the area do you find this particular plant. This organism that which animals are trying to sample, you need also to identify the habitat, where are they found, okay, and where is it likely you are likely to get some of them. Then number two, it is important to mark the area. You need to mark the area. The study has to be undertaken, and you also need to measure the area, the size of the area. So note marking the study area and measuring the size. And then number three, when you go to sample, you need to stand at the middle of the study area. So if this is your study area here, you need to stand at the middle of that. So at the center of the middle of the study area, okay, you hold your gate of quadrant and you hold it aloft, that is above you, okay, and then you twist, move it round, 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 and then you draw, you leave it to fall randomly. So you don't choose the direction, just move it round, 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 and then you release it, okay. So then step number 4, where the quadrant lands, okay, identify the count of all the living organisms enclosed within the boundaries of the quadrant and record the number of each species. So what you're saying is that if this is the quadrant that you have, it has landed, for example, within this region here. If we may assume my duster and the pen and the ruler, these are the things that you're dealing with, the organisms. So what you're supposed to sample, you need to count what is within this particular area, not what is outside, but to count whatever is inside with this particular region. And then, of course, you need to record the numbers, put that somewhere, get the numbers and that. After that, then, after recording, you now make several draws of the quadrant again, just like in step number 4. You repeat the kind of draws that you're doing, random draws, of course, aloft like that, recording each of the results in a table that you're supposed to give. The table will give you the number of draws, the species, the individuals, and the size. Step number 6, you work out, okay? You work out the average of each species from the total number of draws that are being obtained. So of course what we are doing here is when you are recording your work, you may have species A, species B, for example, and then the number of draws. You may have 1, 2, 3. See that? Maybe this ones were 4, this was 3, this was 2, this was 1, maybe 0, maybe 1. So you record, and of course totals here. So you record your work in that manner. So this is the number of draws that the quadrant has been drawn. This is the difference between actually species C, let's say 0, 3, 4. So it is giving you the number of draws. This is why you sum the total. This is 7, this is 4, this is 7. So this gives you the total of this particular organism in that is obtained after 3 draws. Like that, like that, like that. So you record that, and then you work out the average. Okay? The average of each species for the number of draws. For example, in the first case here, this one, total is 7. So the average would be 7 divided by 3. Okay? That would give us something like 2 point something. This one 4 divided by 3. That one 7 divided by 3. So you can be able to get the average. Then from that, you calculate the total population in the study area. Now in the study area, what we're saying, is that, for example, here, our study area was, let's say, 30 centimeters by 30. That would give us around 900, let's say 90 centimeters cubic. That was the area, square, for example. So, and this was the sample area. And then, so what you're saying is that if this 7, let's say 4 divided by average of 1. So we're saying that 1 is obtained after 3 rows, okay? In an area of, let's say, 900 centimeters cubed. About an area like 10,000 centimeters square. From there, you can be able now to estimate the total population that you are able to get in that. Now, from that, I can get the total population in the study area. Total population now means you sum all these totals, divide by the total sum of rows. For example, take all that, divide by that. That will give you the average number of organisms in that particular area, in that quadrant. Multiply by the number of quadrants, it will give you, the number of rows, using the quadrant, it will give you that. Then once you get the total population, you can divide that by area to give you the population density of that particular habitat. A quadrant should always be drawn backwards to avoid biased sampling. So if you are drawing this quadrant ahead of you, you are likely to be selective. It's like you are choosing not to draw. But if you draw it backwards, you cannot see. So biasness is actually eliminated in that case. It should also be drawn several times, and of course, the number of organisms must be counted and recorded at a particular time. We now need to look at the limitations of this important method. What are the shortcomings? It's a good method, but again, it is limited. For example, realize it is unsuitable for estimating populations of large animals. For example, large trees and highly mobile animals. So animals that are highly mobile, for example, insects that are flying. When you cannot place a quadrant on top of an insect, it will actually fly them before you actually sample. Then the method is a bit tedious. It is also time consuming, especially if a large area is to be covered. So it is tedious, time consuming, and therefore that becomes a disadvantage. Lastly, but not the least, you may not have that randomness. In other words, how you draw your quadrant in a given area may not be random at all. And therefore, there is a likelihood that you could be tossing or throwing the quadrant in an area that you are interested in. That now brings in the danger of either underestimating or overestimating, which means we may give a population that is higher than normal, or it may be lower than normal. So to wind up our lesson, I want us to watch this clip that is going to summarize basically our lesson, and then we'll be able to actually look at. So let's watch the clip.
Today we're going to be exploring various sampling strategies, including the use of quadrants. It's usually not possible to look at every single individual of a species within a given area. It's also pretty rare that you'll be able to look at every single square metre within that area too. For that reason, field ecologists try and obtain something called a representative sample. This is when you look at a smaller area that represents patterns that are happening on a bigger scale. You might want to use a quadrat to do that, such as the ones down here. And quadrats are really useful because they can quantify that smaller area that we'll be looking within. They do come in all shapes and sizes, small and big, depending on how many you're going to place and the species that you're looking at. Often they're square shapes like these ones. They can be made of metal or plastic. This one is an open frame quadrat. There's no grids inside this one, you can see, whereas this one is divided into many more grids, and that's what we call a gridded quadrat. You can have lots of different numbers of grids. Sometimes they have 5 squares by 5 squares, giving you 25 in total. This one has 10 on the top and 10 down the side, giving us 100 in total, which can be really useful if we're working out things like a percentage. When you place your quadrat on the ground, there's a number of things that you might want to do. Firstly, you might want to identify the species that you're looking at, either one that's particularly interesting or all of them, if you're looking more generally at biodiversity. In my example here, I'm just going to look at this small flower here, which is known as Bellis perennis, or otherwise known as daisy. I can see 3 individual plants here, one of which has a flower, 2 of which just have the leaves. If I want to assess the abundance of that daisy, I could just count the fact there are 3 plants within the quadrat. This gives me what's known as species density, the number of plants or other species in a given area. If you think of other species though, such as mosses or lichens or even corals that grow under the sea, they don't grow as individual entities. And for that reason we might need a different technique. I'm going to pop my griddle quadrat over the top now and try a technique that involves percentage cover. In this technique, I look at each square, and if my species is present, I count it, and if it's not, I don't. So in this case, I've got Bellis perennis present in 1, 2, 3, 4, 5, 6 of my squares. That gives me a percentage cover of 6%. You may also want to use a pointer, and these pointers can be used to place in a number of locations around your quadrat and see if the species touches or doesn't touch your point. That can be quite useful because it's not based on opinion, the plant either touches that pin or it doesn't, but you can miss some species, particularly if they're small or if they're quite rare. It's not always appropriate just to place one quadrat within a given area. If you want to gain valid conclusions by improving your accuracy and precision, you might want to place a number of these and take a mean or other averages. In my example behind me, I may want to be assessing the biodiversity in this small area of unmown grassland here. I may then want to compare that abundance to the area.
That brings us to the end of this session. We'll